Okay, guys, the next lesson is on something called compound interest with regular payments. Okay, so the thing to note here is that we actually have to use a different website. The reason for that is there's for these questions, and I didn't realize that when I was using the first website, is that there's a difference in your payments, like the payments for this first example, the payments are monthly, but the compound interest is quarterly. All right, so maybe I'll just click over to this one. This is the one we've been using so far, but what you'll notice is that they only have compounding here. There's no difference, or there's no way of switching, or I'm gonna say switching from monthly to quarterly, or adding those both in. All right, so anyways, basically what I'm saying is this calculator is not going to work for us. So we're going to have to use this kind of more plain but simple version of the TVM solver. All right, so I got the link here. I'll also post the link in the channel as well. Okay, so with these types of problems, the only way to get the answer is by using these solvers. The reason for that is because they involve payments. All right, so there's no like quick, easy formula because to take into account payments. Basically, we need to use these solvers. All right, so let's just jump into this first one here. So we're going to calculate how much interest an investment would earn over 6 years if a regular payment of $500 was invested monthly at an annual rate of 3.5% compounded quarterly. All right, so a whole bunch of information here. But basically what we need to do here is we need to kind of dissect this and know what to plug in. Okay, so first thing here, if you look on the TVM solver here, we got these different values to plug in. So the first one is the N. All right, so the N is number of payments. Okay, payments. So in this case, N is going to equal over the 6 years. So we got 6 years, and it's compound, or not compound, and every month we're investing it. So I'm going to multiply that by 12. Okay, so notice that, it's not times 4 because it's compounded quarterly, but it's multiplying by 12 because we're putting in 12 payments a year. Okay, so 6 times 12 is 72. Okay, so I'm going to plug in 72 here. The interest rate, okay, so we can just plug that in. You don't need to change it to a decimal, so you're just going to punch it in as 3.5. Okay, so present value is how much your initial investment is. However, since we're doing payments, there's no actual initial investment, okay, because we're just adding in $500. All right, so you may think, oh, the initial investment was 500, but it would be like the principal, right? So this payment, there's no principal, it's just payments. I guess that's the best way to explain it. All right, so in the payments here, I'm going to plug in 500. Future value. Okay, so calculate the interest. It's kind of a two-step process here, where we're going to get the final value, and then subtract how much we put into it, right, to get the interest. So, so we are actually going to find the future value here. So P/Y stands for payments per year. Okay, so again, we're doing $500 each month. So there's 12 payments a year. And C/Y is like the compounding periods per year. So this is compounded quarterly. So this would be 4. Okay, so these are the values that we would plug in to this TVM solver. Right? And so I'm going to solve for future value. Okay, so we get 39,982. Okay, so let me just write that down. So future value ends up being $39,982. So let's go to dollars and cents here. So I'm just gonna, if I click on there, it'll you can kind of toggle back and forth here. So it's 6 cents. All right. Now we want to figure out how much we actually put in. All right. So this we're going to do by hand. All right. So there was So how can I put invested? I'll just write invested. So it was $500 a month. So $500 a month for 6 years. So we're going to 500 times 12 times 6. All right. So that number there is 36,000. Okay, so we put in a total of $36,000. Yeah, actually, what you may have noticed is that the n here, the number of payments, is the same as 12 times 62. So these will be equal. All right, so to get the interest, it's going to be equal to the final value. So that was $39,982.06 minus the amount we put in over the 6 years. So that's 36,000. And when you subtract that, we're going to get $3,982.06. Okay, so that's the amount. That's the amount of interest. All right. Cool. All right, so let's go on to the next one. So let me just scroll this up here. All right, so we want to calculate the number of years it would take if you made regular payments of $1,000 a month into an investment that paid an annual rate of 5.25% compound quarterly to be worth $150,000. How many less days would it take if the annual? Okay, so here we're comparing two different investments. All right, so let me just kind of clear this here. Okay, so our payments are 1,000. So a month. All right, so payments per year would be 12 into investment at a rate of 5.25%. Compounded quarterly. Okay, so compounded per year would be 4, and we want this to reach $150,000. Okay, now with future value, just remember that we're going to plug it in as a negative. All right, and we also need to plug in the n. So the n would be, let's see here, the number of payments. So payments, so we're doing per month. Oh, my bad. Sorry, we are solving for n. Okay, so this is the data that we want to put in, and we're going to solve for n here. Okay, so 115.69 is what we get for n. Okay, so n is 115.69. Okay, now the thing is, this is not the number of years. All right, this is the number of payments. Okay, so to convert this to the number of years, since we're doing a payment of since our payments are per month, what we actually have to do here is divide it by 12. Okay, so I'm just going to punch that in here. So 115.69 divided by 12. All right, so it'll take approximately 9.6 years, or 2 decimal places. So 9.64 years. This is the number of months. Cool. All right, so next up, we want to know how many less days would it have taken if the annual interest rate would have been 7.25% compounded weekly. Okay, so this we're going to just make an adjustment. So our payments are the same. Change this to 7.25. Compounded weekly. Okay, so this would be 52 compounded periods per week. Still making the same number of payments, and we still want some amount. Okay, so let's solve for n here, and we get 107.04. Okay, so we'll just call this part B. We'll call it part A. All right, so N is equal to 107.04. And this would be, again, the number of months. Okay. So it kind of makes sense, right? If we were going to compound it more often with a higher interest rate, it's going to take us less time. Okay, so if we subtract the difference, this would be, so how much quicker would it be? Right? It would take 115.69 minus the 107.04. And that's going to give you, I'm going to show off some math skills here, 8.65 months. Now, when I say I'm going to show off, I better make sure I get it right. So let me just double check. Yeah, that's right. Okay, so that's number of months. Now to get how many less days, so it's going to take 8.65 less months, and let's just approximate that there's 30 days a month. We can just use that estimation there. All right, so we're going to multiply that by 30, and uh, 259.5, so we'll call it 260 days. Okay. So it'll be 260 days. Yeah, so 260 more days, 260 less days, sorry, not more, to get to that. Cool. All right, now this third example. Okay, so June deposited $300 per week into a certificate, into a CD that paid an annual rate of 4.9% compounded monthly. Julie made a one-time deposit in the same investment. So if they both had the investment for 8 years and the future value were both the same, what was the amount of Julie's one-time investment? All right, so, and then compare the rate of return on both investments. All right, so this is a lot of stuff. Okay, happening here. So let's just kind of break this down. So they have the same future value, and we want to find Julie's one-time investment. Okay, so they give you all the details about June's investment. So what I'm going to do first is, so step one, I'm going to lay this out. Step one, we're going to find the actual future value. Okay, so to do that, we're going to figure out the future value of June's investment. All right, so it was $300 per week. So let me just clear that. So the payments were $300 per week. All right, so payments per year would be 52. Annual interest rate of 4.94%. 4.95%. Compounded monthly. Okay, so there's 12 compounding periods per year. We want to find the future value. We'll start off with nothing. All right, so present value, or the principal, was 0, and n in this case. So we have, again, how many payments? So payments per week. So 52 payments per year. Yeah. For 8 years. Okay, so 52 times 8 would be the total number of payments. All right, so that is 416. All right. All right. Okay, so let's get the final value. So the future value is $152,983. Oops. $152,983. And let's go down to the closest cent as well, 32 cents. Okay, so that's our first step, is to get the actual final value of this investment. So then let's figure out what Julie has to put in to get that actual amount. Okay, so find Julie's present value. Okay, because it's not a payment thing. Okay, so I'm going to leave the future value the same. That's where we want to get to. She's not making any payments. Okay, and we're going to solve for the present value. Okay, so again, it's still 4.95% compounded monthly. Okay, so the n in this case would be the number of actually compounding periods. Okay, so since this is like not a payment calculation, it's just a one-time compound interest one. We could actually solve for this by hand, but I'm going to just use this TVM solver. Okay, so in this case, n would be again, it was compounded monthly for 8 years. Okay, so so the number of compounding periods would be 8 times 12, which is 96. Okay, so this is 96. And we want to figure out what this present value is. Okay, payments of year, I can't remember. Actually, I think we have to make this the same as the compounding periods per year. All right, so the payments, so present value there would be $103,042. Okay. So present value for Julie is 103,042.69. Okay. Okay, guys, just give me 1 sec here. I want to actually double check this with the other TVM solver. I'm not entirely convinced I did that right. So 1 sec here, guys. Okay, so I'm going to do the same Julie's question here, using the old one. Because this one here, I may have screwed up this part down here. So I just want to double check that. Okay, so so the final value, the future value was the 152, but again, I'm going to plug it in as negative. 983.32. The annual rate of return was 4.95. Number of periods. Okay, so this is compounded monthly. And so 12 times a year over the 8 years was 96, I believe. Yeah. And let's just, it was again compounded monthly. So is that the same? Oh, okay. So yeah, good thing I double checked. It is the same number. All right. So yeah, so when you're doing these ones here with no payments, make sure the compounding and the present value are the same. Okay, so this is Julie's present value. Okay, so that answers the first question. We'll just circle that. Okay, so that's the present value. Now, next up, asks you to this part, call it part A. Part B, we're going to compare the rates of return. Okay, so this is this part right here. All right, so rate of return. Rate of return is your basically what you're going to do is you're going to take your final value and divide it by how much you put in. All right, so I'm just going to call it invested. Invested capital is the invested capital is the kind of fancy way, but let's just put a dollar sign. All right, so let's compare the two. So first off, let's go with figure out what June put in. Okay, so June invested. What was it? It was $300 a week per week. $300 a week for 8 years. Okay, so I'm going to multiply that by 52. Multiply that by 8. All right, so as a result, Let's see what that number is. 300 times 52 times 8. Okay, so it ends up putting in 124,800. Okay, so to get her return on rate of return, okay, June ROR, I'm going to take the final value, which is 152, 983, 32, and I'm going to divide it by 124. 800. Sorry, that's pretty messy writing. All right, so let me just kind of put that one. 124, 983.32 divided by 124, 800. Okay, so we get 1.22. Let's go. Let's just round it to 6. Okay, so the rate of return is actually going to equal 22.6%. Okay, so the reason it's 22.6% is this one actually represents the investment. So whatever you have left over on top of the 100%, right, or the one which is 100%, whatever you have on top of that is the rate of return. So hopefully that makes sense. Okay, so the decimal part, you're going to convert it to a percentage by multiplying by 100. So June's rate of return was 22.6%. Okay, so if we do the same with Julie, and I'm hoping that I can write on this. So Julie, ROR, we're going to do the same thing, 152, 983.32. But she only put in 103, 042, 69. All right, so 3 down. Yeah, so anyways, just a little thing here. My tablet, it doesn't pick up the writing down here, and it gets all messed up. So that's why this looks like the writing of a 4-year-old. I don't know if 4-year-olds can write, but whatever. Anyways, I still have an idea what the numbers are. So let's just do this calculation. 152, 983, 32. And let's divide that by the 103, 042, 69. Okay, so this time we got 1.48. 1.48, and let's go one more decimal point. So 1.485. So that would be 48.5% rate of return. Okay, so those are your two rates of return. All right, guys. So yeah, so this is kind of like a different version of the TVM solver. Actually, this is the same interface as what's within the graphing calculators. Okay, but yeah, so hopefully that made sense. Yeah, so you guys, that's today's lesson. All right, so guys, hope you guys are doing well. Take care. Ciao.